So we just did a quick look at elements, and we know that elements are typically atoms, and we described
Hey,
atoms
welcome
as
back.
the smallest part that
So, we're going to
contain
take
the
a
actual
look at the
properties
atom.
of whatever they
We had
are.
talked to atom
Now we
before,
know for a
and we
fact
had
that there
said
are
that it is
actually
the smallest
smaller
part
parts
of an
in an
element
atom. We
that
know that there are three
retains its
parts.
unique properties.
There's two parts that
We
are
know there are
inside
smaller parts. Two of these
called the
parts
nucleus,
are
and
found
there
in the
is
nucleus.
one part on the outside, uh, which is in
The other is found outside the nucleus,
as in orbit,
and it is found in
circles
orbit
around the
going
nucleus.
around the
So
nucleus,
the
which is in
inside
the
part,
center.
the nucleus, is made up of the proton, which you've probably already heard.
We know that one of these parts in the nucleus is the proton, the other is the neutron.
Positive charge.
The proton has a positive charge,
At all.
the neutron is
Outside,
neutral
the part
and
that
has
orbits
no
is
charge.
called the electron.
The particle that orbits the
This
nucleus
has
is
a
called the
negative
electron and
charge.
has a
So
negative
right
charge.
now, we're going to take a look at protons and electrons. We currently know they exist, but historically, how did we come about that knowledge? And so that's what we're going to look at here in a second. So the first thing we're going to look at is the discovery of the electron.
So first we're going to take a look at how did we discover the electron. This was discovered by the cathode tube ray experiment.
Same thing. The scientist is J.J.
This experiment was discovered by J.J. Thompson.
Let's go ahead and set up how this was kind of made. So it's called a cathode tube ray because it's literally a tube.
So I'm going to draw kind of a brief schematic of the actual setup of the experiment.
A little stand that stands it up. Now, there is a current.
This right here is the cathode tube.
So there's a box over here.
There is some wiring. It goes to a power source. Electricity goes to these wires on each end.
Okay, that's the electricity box. Now, whenever this happened, there was a gas inside. And that gas produced a beam.
Inside is a gas, and when the electricity was turned on, there was a beam that filled the cathode tube.
Is it made up? So, initially, he just grabbed a...
They did not know exactly what this tube was made out of. And so they went through a series of experiments. First, they used a magnet because they thought that it may be some kind of a charged particle. Whenever a positive magnet was placed on the tube, you'll see that the actual stream bent towards it.
And so then he flipped the magnet around and he put a different charge on it.
Whenever they put a charge or a magnet that was negative next to the beam bent away from it.
Okay.
The beam was attracted by the positive charge and repelled by the negative charge. This led Thompson to believe that the particles in the beam were negative and had a negative charge. Later, the size and all that would be discovered through some different experiments. Now let's take a look at another experiment, and that is Rutherford's gold foil experiment. So this is really going to be the discovery of the nucleus, but inside is the proton which gives it the positive charge, which is seen in the experiment. So he had a piece of gold foil in the middle here. Then he had the special physics gun that shot tiny particles called alpha particles. Here's a symbol for alpha, and he's shooting it at the foil. Around the foil, he had set up a sensor to detect any particles that may pass through or even bounce off. So as the particles come out, they would go through and they could hit the other side if they touched nothing. Rutherford was not expecting the particles to pass through. At this time, we had the belief that atoms kind of had this, what they called pudding idea, plum pudding. And so it was very tightly packed. These little black marks represent the raisins in plum pudding or the nuclei. And so he would think that as the particles hit it, they would just reflect off since it was very compact and dense. So as he began bombarding it, he found that almost all the alpha particles passed through, okay, represented by those light blue little dots on the back of the detector. So this led him to believe that there was a lot of space and that the nucleus of the atom was small. The second thing he saw was reflections coming back and even deflections off of the course. So many of the particles changed course. Since the alpha particles are positive, he knew that whatever they were encountering must have been positive also. Therefore, he knew that there was a small positive center to the atoms of gold foil. Later, we would find out that in that small positive center or nucleus, there would be a proton giving it the positive charge. That's it for now. See you next time. Bye-bye.